Everyone. Hello everyone, my name is Indrani Ravindra Kumar Hiremat from the college Sri Siddheshwar Women's College of Engineering. My branch name is Computer Science Engineering. I am the Division D student. Today I am explaining the one physics concept which is the atomic packing fraction. Here we are going to calculate the atomic packing fraction in the simple cubic unit cell, body center cubic unit cell, and also in the face center cubic unit cell. Now we are learn one by one. So let's start. First of all, we have to learn what is the atomic packing fraction. The atomic packing fraction is the ratio of the volume of atom in the unit cell to the volume of the unit cell. Here we have the one formula of volume of one atom, which is equals to 4 by 3 pi r cube. Here, it is the definition of the atomic packing fraction. Now we are going to calculate the atomic packing fraction in simple cubic unit cell. For the simple cubic unit cell, we have the number of the atom per unit cell, which is equals to 1, and the edge length which is edge length A, which is equals to 2r, and the volume of the unit cell A cube, which is equals to 2r cube. Because we have the value of the A, which is equals to 2r, hence we take here value of the A cube, which is equals to 2r cube. By calculating, we get the value which is equal to 8r cube. Hence the volume of the atom, which is equals to 1 into 4 by 3 pi r cube. Hence the APF for the simple cubic unit cell, which is equals to 4 by 3 pi r cube upon 8r cube. We substitute all the above values in this formula, then we get the value of the APF, which is equals to pi by 6, which is similarly equal to 0.52. So it is the value for the APF value for the simple cubic unit cell. Similarly, we are going to learn the APF in the body center cubic unit cell. Hence now we have to know the number of the atom per unit cell in the body center cubic unit cell, which is equals to 2, and the body diagonal, which is equal to 4r, that is the root A. Hence A is equals to 4r by root 3. The volume of the unit cell, which is equal to A cube, which means here the value of the A, which is equals to 4r by root 3. Hence we take the value of the A cube, which is equals to 4r upon root 3 cube. The value of the atom, which is equals to 2 into 4 by 3 pi r cube, which is also equals to the value 0.68. Here the atomic packing fraction of the body center cubic unit cell, which is equals to 0.68. Now we are calculating the atomic packing fraction for the face center cubic unit cell. First of all, we have to know the number of the atom per unit cell in the face center cubic unit cell, which is equals to 4. For the face diagonal 4r, which is equals to root 2a, we find the relation between the A and R, which is equals to 4r by root 2. The volume of the unit cell, which is equals to A cube, and also equal to 4r upon root 2 cube. The volume of the atom, 4 into 4 by 3 pi r cube. We substituting above the all values in the formula of the APF. Hence we get the value of the atomic packing fraction, which is similarly equal to 0.74. This is for the face center cubic unit cell. Now we learn the atomic packing fraction in the cubic unit cell, simple cubic unit cell, body center cubic unit cell, and the face center cubic unit cell, and we got the both three values according to the formula. Hence in the last slide we are going to see what is the summary of the atomic packing fraction. So as usually we are calculating the atomic packing fraction in 3 types of the cubic unit cell. First, we calculate the atomic packing fraction in simple cubic unit cell, which is equal to 0.52, and in body center cubic unit cell, the value of the atomic packing fraction, which is equal to 0.68. Here the value of the body center cubic unit cell, you can see 0.68, which is similarly equal. And for the face center cubic unit cell, the value of the atomic packing fraction, which is equals to 0.74. Here you can see the value of the unit cubic face center unit cell. On substituting all the values in the formula of the atomic packing fraction, we get these values for 3 cubic unit cells. And the summary of this learning of the APF is, we see in the face center cubic unit cell, the atomic packing fraction efficiency is the maximum. We can compare these all 3 values, hence we got the atomic packing fraction in the APF, which is maximum in the face center cubic unit cell. To calculating the atomic packing fraction, first of all, we have to find the relation between the A and R. For the simple cubic unit cell, the relation between the A and R, A which is equals to 2R, and the relation between the atomic packing fraction for the A and R, A which is equals to edge length and R which is equals to radius. And for the body center cubic unit cell, we find the relation between A and R, which is equals to A equals to 4R upon root 3. And for the face center cubic unit cell, we find the relation, that is the R, A is equals to 4R by root 2, and this we find